Hi, I'm Reed, and this here is Charlie, the ping pong playing robot. It's the end of the month, and so I thought I would bring you up to date on what I've been working on. I've been messing with the mechanics of the system. I've been working on the homing, and I redid all the wiring. The mechanics are nice and smooth. There are no tight spots. Everything moves smoothly, and I'm really happy with the way it's turning out. The way homing works is when you power up the robot, it's kind of disoriented. It doesn't know what pose it's in. And so the purpose of homing is to make it so that it knows when its arm is level or when it's in the middle and so on. So I'm going to run this through the homing sequence and hopefully they'll be impressed. But one moment. So the way homing works is each axis keeps going until it hits a limit, and then it finds the limit again, and then it backs off by a fixed amount until it's at, in this case, right behind it, and it does it for the next axis, and it cycles through the axes. All these axes go a lot faster than it's doing right now. That's 3 axes. Wrist, and what you do is you end up with the robot in the middle, facing the table, hands behind its back, ready to play ping pong. And it works pretty good so far. I'm happy with it. One moment, I'm going to turn it off. What happened was, this whole thing, the part that moves, weighs about 75 pounds, so I was learning how to use it and running it back and forth and back and forth, a lot of acceleration there, and the motor was too small, and I fried the motor. Stupid. And then on the hand, what happened was, I was doing that homing sequence you just saw. The arm went up all the way, and the hand hit the ceiling, caught on some cables, and bent this bracket right here. So I have to rebuild this bracket. It's stupid. All the wiring would have been cleaned up, not quite redone. All the wiring comes up. Everything is coaxial so that I can do multiple turns. And then I put in a cable carrier so that all the wires exit outside towards where I'll be sitting running the show. Take you over here. This is the base linear axis of the timing belt that comes around here, and to make it go back and forth. This is a gearbox, and this is the original gearbox, and this is the new one. So this one can handle about twice as much torque, and I think I won't be blowing it this time. The old motor, this is the old base axis motor, this is the new base axis motor, 400 watts, 800 watts, and I did the calculations this time. I'm pretty sure it's going to work this time. On the computer end, I have a Linux workstation. It's running a custom real-time kernel, and this main window is the main window from the Linux CNC open source software project. And my whole project is a fork from that. Then, let's see, I've got a control panel so I can monitor the position, the velocity, the torque, and so on. I've got a kind of a bird's eye view of what the motor, what the robot pose is like at any given time. And then I've got a, I've got a GUI for the image processing that I do for ball tracking and so on. There's a lot of code behind that. The workstation itself has a couple of cameras hooked up, and they go over here. I have a couple of industrial strength cameras mounted on the ceiling. Those will go up to 70 frames a second. They're about the same resolution as high-def television, and so I can triangulate with a lot of math and track the ball. And I got a lot of that working. That'll be a couple of months. I'll talk about that. There's another board in here that deals with motor control. It's got two cables coming out. One of them is for an analog servo motor controller. This replacement motor that I have, I had it on hand, and it's a different kind of motor than the ones that I wanted to use, but it saved me $1,000. So there's that one, and then the other cable is for stepper motor controls. I got the wrist and the hand motors, and they seem to work. I've got limit switches on each axis so that I won't go off the deep end, and all those feed into IOs back into the software, so I can make sure I'm not going out of bounds. And then these here are EtherCAT servo controllers. EtherCAT is a really, really good high performance bus. And let's see, right now you can see that two of these for the wrist and the shoulder, the waist and the shoulder are in standby. And the one for the base is showing an error code because I blew it up. So everything that's not broken is pretty much working, and I'm down to integrating all the parts now. I'd have to say I'm pretty happy with it. I think I'm going to not make any progress at all for the next month or so because I'll be on the road. But when I get back, I'll be fixing these broken axes and working more on the software. So stay tuned.